Hello, this is my final product, and or just my final notes. No, we had one, so. Oh, oops. What are the requirements for this one? Final, didn't really. 2, 3, 4, 8. 1. Catch your Euler. 2. I can do 2. 3, 4. Power C's, okay. I'll be doing method of undetermined coefficients. So for this, we have a second order linear differential equation. So we need two parts, a homogeneous and non-homogeneous part. And to get the y of c part, the complement y of sub c, you have to find the roots and get the characteristic equation. So equal, I'll just find the roots first. So this is y of sub c, turn r squared plus 4r equals 0 because this is homogeneous. So the right hand side equals 0. If you do this, minus 4r minus 4r, r squared equals negative 4. And if you take this whole equation, you get r equals, you can't take a square root of a negative number, so it will be a square root of negative 4 times I. So we have here a complex imaginary. So the characteristic equation for this would be in the form of y sub c equals c1 cosine 2x plus c2 sine 2x. Yes, that seems sound right. Over here we have, on the right hand side we have a quadratic and we have exponential, so we'll be doing two trial solutions for this one. So to have a quadratic trial y sub p's quadratic would be y sub p equal to ax plus bx plus c, and exponent exponent the y sub p would just be equals a e to the x. Apologize for that noise, that's just my washing machine. Okay, let's start off with the quadratic particular solution. So let's do y sub, we already have y sub y prime of p. So this would be, ax squared. 2x plus b plus c is gone. Y double prime p equals 2x. So we can do this right now. We can do no, it's 2a. Ax would be gone. So plug into diff-q 2a plus, we don't need the y, we don't need the first derivative, 4 ax squared plus bx plus c equals x squared. Okay. Expand this out. 2 plus 4ax squared. 4ax squared plus 4bx plus c equals x squared. We don't have any b terms, so b can turn to 0. Focus on a. X squared. So for this, times 1 for a to match up with this, a would need to be 1/4. And now we have, the left is 2a and c. Since there's no c over here anywhere, we need to have 2a plus c equals 0. We found 2a to be 1/4, so we'll be 4c. 4c 2a plus 4c equals 0. This would be 1/2 plus 4c equals 0. 4c equals negative 1/2. Got ahead of myself. C equals negative 1/8. That is the particular solution for the quadratic part. Now let's do particular solution for the exponential part. Y sub p prime, derivative of e to the x, we have, so this will just be a e to the x, y double prime equals a to the x, and y triple prime. No, that's all I need. So it'll just be the same because just e to the x and with a constant in front, or multiply by a constant in front. So let's plug this into the equation. So a e to the x plus 4 a e to the x equals 3 e to the x. We can see from here, this is 5 a e to the x equals 3 e to the x. This needs to match up. So multiply. A just needs to be 3/5. A just needs to be 3/5. And yes. Over 5 e to the x. That will be our y sub p. Or just our full solution would be, well, full general would be the complementary part, and the particular part would be c1 cosine 2x plus c2 sine 2x plus 1/4 x squared, 1/4 x squared plus minus 1/8. This over here to have more space. 5 plus 3/5 e to the x. Okay, IVPs for 0, 2. Okay, so 0 equals 0, y prime equals 2. Okay. Plug in 0, cosine 0 equals just c1, sine disappears, so c2 is gone. 1/4 times 0 cubed, so 0 plus 0 minus 1a plus 3/5. So this will be C1 equals 1/8 minus 3/5. 540 minus 2440. C1 would be negative equals negative 19/40. Okay, C2 now, take the derivatives, so this would be equals 2, so y prime equals 2, negative 2, sine 2x plus 2 cosine 2x plus 1/2 x minus 0 plus 3/5 e to the x. Okay. 2 equals C1 doesn't matter. 0 plus 2 C2. I forgot to add C2 there. So C2 caret C1. And we have plus 0 plus 3/5. So 2 C2 equals 7/5. 7/5 divide by 2 times by 1/2. C2 equals 7/10. Okay, so let's plug in this whole equation. This will be our whole solution with IVPs installed. Nope, not that. Oh my god, so sorry. C1, as we've solved, negative 19/40 cosine C2, 7/10. Separation of Lars. Let's do this one first. Modified exponential decay model at the rate of 1/3 mass raised to the 4th power, so 10 grams substance times units. So years and mass. So function of time, A would be dm dt equals 1/3 mass force power. So this equals 1/3 m to the 4th with a IVP of m0 equals 0. Solve the D. Okay. B dm dt. Let's leave that there for now. 1/3 m to the 4. Get m to the 4th to the other side. M to the 4th power. So this will be 1 m to the 4 equals dm dt. Wait, this is decay, so this isn't growth. Equals -1/3. Step 2, get m by itself times dt, separation of variables. So 1 m to the -4 dm is equal to -1/3 dt. Take integral of both sides. Minus that 1/3 m to the equals -1/3 t plus c. Okay, so times this by 3. So this would be 1m3 equals -t plus c. I'm sorry, my brother was talking to me, so no, this is wrong. This is go for negative, so times 1, -1, 3 equals t minus c. I'll raise this up. Just flip it around. M3 m to the third power equals 1 t minus c 1/3. Got this. Equals 1 t. Solve IVP. Okay, m equals 0. IVP, yeah, so solve for the constant 0 equals 1 equals 1. No, it's 10 grams. So 10 is equal to 1 0 minus c 1/3 to the power of 3 1000 equals 1. Just flip this around, just flip all this. C and add a -2, so c is equal to -1/1000. So I'll plug this in. Plug this in to m equals 1 minus t minus 1/10 to the third power. This seems right. That is B. C, what is the half-life? This is IVP of half-life. Half of the substance is gone, so IVP. We want to solve for time, so M t equals 5. So let's do that. 5 equal to 1. Just eliminate the third power. It's here. T minus 1/1000th. So 125 equals 1 over t minus, flip this around, so 1 over 125 is equal to t minus, this is a minus minus, so this becomes a plus. Yes, so C is a yeah, okay. Plus 1/1000 minus 1/1000, 1 over 1000. So t equals 125 minus 1000. 1 divided by 125 minus 1 divided by 1000. 0.007 units. Years. Years, okay. D, IVP. Now we're looking for, oh, it's another, okay. Find time again. So M 1.5 equals MT equals 1.5. 1.5 to the third, 3.38. 3.38 is equal to 1 over t, flip this around, so 1 over 3.38 equals t plus 1 minus this, so t is equal 1.38 minus 1 divided by 3.38 minus 1. No, minus 1 divided by 1000 equals 0.295 years. So units, A, B, C, D. Okay. 3, I can do 3, right? 3, okay. Newton's law of cooling, so dt equals, just have to look up the formula, equals K TL minus TM. Like the first one, let's make it simple. Yeah, just times this by dt. So dt is equal to, and divide by delta t, I guess. Say space, delta t. So 1 over delta t dt equals k dt. This will be now integral of both sides. Should be both of themselves. Yes, so ln delta t equals kt negative kt plus c. Plus c, so e eliminate this, delta t is equal to k c e to the negative kt. So this will equal Tm To minus Tm equals Cek negative T plus Tm, so To equals Tm plus Ce negative Kt. IVP time. That's the general solution. It's 16. Oh, wouldn't this be 0? This should be 0, 0 then. This. So we're solving for constant first, we're not solving for k yet. 0 equals 0. So this will equal 0 or 0 equals Tm plus C1 e to the 0. So it's To C1 equals To minus Tm. Yeah, that checks out. What is the temperature of the can when it's initially placed in the... So we have two IVPs. IVP. 1 Celsius in 5 minutes, so... Y 5 equals 1. So this will be 1 1 is equal to Tm plus To minus Tm Ce k negative Kt. So this will be what's Tm room temp, place in the kitchen. Okay, so equalize to room temp, so Tm is 16. 16 T replace everything with 5 gas, so 5 1 equal to 6 plus TL minus 16. Take out the C, E to the negative 5 negative 5k. And for IVP, Y equals TO minus 2. So guess it is TO minus 1. Minus 1, TO minus 1. So TO minus 2 is equal to 16 plus TO minus 16 e to the negative 11k. Okay. TO TO minus 2, TO minus 1. What's the temperature? Okay. TO minus 1, TO minus 2. I solve for K first. 16 plus TO minus wait, TO in this case T 16 plus TO minus 2 minus 16 k. So, okay. Solve for k. Okay, so 16 plus TO. You wanna know what TO is? We need to find that. So TO minus 1 minus 16 equals 16 e to the negative 5k equals 16 TO minus 2 minus 16 e to the negative 11k. So we eliminate 16s, the plus 16s. TO negative 17 e to the k is equal to negative 18 11k. Multiply these, eliminate the 5. So 5k TO minus 17 is equal to TO 18 T naught plus negative 6k. Solve for k. Divide. So ln e. E. So t minus t naught minus 17 t naught minus 18 equals negative 6. Okay. K. ln right now. Just put in ln. This gets to 45. I'll just cut it right there because it's taking a bit too long. Times this by negative 1/6. K is equal to negative 1/6 t naught minus 7 ln t naught minus 17 t naught minus 18. That doesn't give me the temperature. Okay, this is bad. Temperature. If I plug this back in now, just any equation. Okay, so plug this back in over here. So T, after I do law of cooling, T 16 Celsius plus, no, because this would just turn to 1. This would be 16. It's not, didn't start off 16. Didn't start off 16. Maybe this one. No, that's not. Maybe it's 16, like that. 16 plus T naught minus 17 e to the negative 5k. I can, okay, let's just, if we need to be, you just, how long until c, which is that one, which is basically the half-life part. So just for b, if I don't ever find out, would be t equals 20 and 20 I need the temperature. How do I do this one? So this will just be in 20 for part B, 20 and 20 is equal to 16 plus T naught. I don't have the heat. That was bad. Initial temperature. I'll just cut it right there. I don't think I have enough time to do this. Yeah, this is my like 2 1/4 problems done. I may have forgotten to check Canvas, and that'll be it. So thank you, Professor, for allowing me to this course, and thank you for all the materials you uploaded and all the videos. So thank you, Professor Hubbard, and this is my video.